When an acid reacts with a metal salt of a hydroxide base, we get a neutralization reaction. And the neutralization reaction always produces two products, a salt, which a salt is just an ionic compound. It's a generic word. It doesn't necessarily mean sodium chloride. So it produces a salt and water. So the first equation there is a general equation. So a strong acid will react with a strong base to make the salt, a metal salt with an ionic compound, metals and nonmetals, and water. Now the net reaction, or overall what's happening, is that the proton, the H plus from the acid, the strong acid, is reacting with the hydroxide ion, the OH minus there, and those two together make the water. So there's your neutralization reaction. That's what's happening right there. So here's two examples. So you see that the H is reacting with the OH. See, that's making your water. There it says always making the water. And then it also says that you make a salt. Well, how you make a salt, it comes from the metal, which is the K, and it's going with the Br. Now, thinking about this, to figure out how they go together, we have to think about their charges. So just in the red pen, I'm kind of thinking. So a K plus and a Br minus would go to make a KBr, and that's the salt. So the neutralization reaction says HBr plus KOH, and that forms KBr plus water. So a salt and water. Now I threw in a second example because because potassium and bromide both have a +1 and a -1. It looks things are just kind of switching around. It's called a double displacement reaction. On the bottom one, it has coefficients because we had to balance it. But let's take a look. It's very similar. So this is a strong acid and a strong base, the hydroxide base. And here we have H. There's my H, so that's the H plus like we had before. And here's my hydroxide ion, OH minus, right? And so just thinking about it in general, those two things are going together to make my water. So here's my water like we had before. And it also makes a salt. So this time I have magnesium, that's the metal, and it's going to go with the chloride. Now magnesium is a 2 plus, and chloride is a 1 minus. So you see we get this formula, magnesium chloride, from my ionic compound, and that's my salt. So on the second one, it looks slightly different. It's a strong acid and a strong base. They're making a salt and water. It ends up having coefficients because the magnesium's 2 plus and the chloride's 1 minus. So a neutralization reaction of a strong acid and a strong base is an important reaction in the acid-base chemistry.